Atomic naming. Atomic naming.
Atomic naming.
What is it? Atomic naming comes in two flavors. That's ionic and covalent. Ionic is between a metal and a non-metal, and covalent is between two nonmetals. For ionic bonding, you have to know the charge of the atoms you're using, and they have to add up to 0. It's fun! Figuring out charges is easy. The first 3 columns are +1, +2, and +3. We don't talk about columns 4 through 12. Confusing! Noble gases are inert. They don't bond ionically. In fact, they almost never bond covalently. Group 17 has a charge of -1. Group 16 has a charge of -2. And group 15 has a charge of -3. Group 14 could be plus or -4, depending on if it's a metal or a non-metal. And group 13 is +3, just like group 3. Naming. There's only one way 2 atoms can bond ionically, so you don't even have to write a prefix. Examples are fun. The formula for sodium chloride is NaCl, because sodium's charge is +1 and chlorine's charge is -1. But the formula for calcium chloride is CaCl2, because calcium has a +2 charge. Naming. It's so easy. Covalent bonds, like dihydrogen monoxide. Water. You need prefixes on covalent bonds, except on the first one, when it's 1. The prefixes are mono, di, tri,
tetra, penta, hexa, hepta, octa, nona, deca.
Simple! But drop the A if the prefix is going in front of oxygen. I don't even know why, but it's fun! When naming, the first one is the furthest to the left on the periodic table. Let's squeeze hydrogen between nitrogen and oxygen. That seems as good a place for it as any. Now you know how to name. Throw a party! A big huge atomic naming party! And invite all your friends! Big huge atomic naming party! Party! Atomic naming party!